Hello, this project is based on creating a diabetes prediction model. We are going to use support vector machine as a classifier. This is how a simple SVM looks like. There is a hyperplane which is this red line which separates different classes and it's created. These are the different classes blue and green, and it is created in a way to be as far as possible from the nearest data points which are these blue and green. Now let us look at our diabetes data set. Here you can see there are different columns. First is pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and then outcome. Depending on these 8 columns, we are going to predict the outcome, whether the person is diabetic or not, where 1 means the person is diabetic and 0 means they are not. Let us move on to our code. So we will first import all the necessary libraries such as pandas, numpy, standard scalar, test and split, SVM, and accuracy score, which are from NumPy, Pandas, and Sklearn. Then we are going to load our database into the diabetes dataset variable using panda.read underscore CSV. You can skip this line as it is just used to show the document. Yeah, you can just skip it. Next, we will just print out the top 5 rows of our database using dot head. Then we will check the shape of our data set, indicating how many rows and how many columns we have. Then we will use dot describe to get the statistical measures of our data, such as, like, as you can see, it gives how many rows we have or count we have of our pregnancy, what you can say, uh, data points, then mean of those, then standard deviation, the lowest value, the highest value. Similarly, it is done to all the rest of the columns. Then we will use value counts to display the number of occurrence of unique values. And since we only have ones and zeros in the outcome column, uh, only they will be displayed along with their counts. As you can see, we have 50 zeros and 268 ones, where zeros is non-diabetic and 1 is diabetic. Then we will use group by function on our outcome column of our entire database. This will group up all unique values which are zeros and ones, and display the mean for the rest of the columns corresponding to it. As you can see, we have got the outcome column, and those two are these unique values, zeros and ones, and the rest of the columns are displayed with their mean values. Now we will separate the data and labels. So first we will take x variable in which we will put all of our columns except for the outcome column. So basically what we did is, we took the entire data set and just dropped the outcome column. For y, we just wanted to have outcome column, so that is exactly what we did. We just put only the outcome column in it. Now let us just display what our x variable looks like, and this is how it is. To You can just check that all of the columns are included here except for the outcome column which you are going to predict. We do the same with y variable and print out all of its values. Now we will initialize standard scalar in scalar variable and fit the scalar to the feature data x using fit method. This will compute mean and standard deviation for each feature or value in the training data to be further used to scale the data. We then use transfer method of scalar to standardize the feature data. So each feature has a mean of 0 and standard deviation of 1. Then we print the standardized data. As you can see, we have now successfully standardized the data and store it in the x variable. Now we print both the values in x and y variable, where x has standardized data and y is our output column. Then we'll use the train test split from sklearn, using the test size of only 20% and training size of 80%. Then we use stratify y for proper proportion of our uh, output column, so that our data is not imbalanced while training, with a random state of 2. Then we will just print out all of the shapes of our x train and x test. Then we will start training our model. We will initialize svm, support vector machine, with kernel set to linear into our classifier variable. We use the linear kernel here because the data can be separated by a straight line. Then we train our SVM classifier on our training database xtrain ytrain. Now we use our train classifier to predict the outcome on xtrain using classifier.predict and store it in xtrain prediction variable. Then we will compare this predicted value with the actual value using accuracy underscore score and store it in training data accuracy variable. Then we will just print out the accuracy score, which we got to be 78%. We will do the same step with on the test data, where we will use our classifier model to predict on x test. Then we'll store this value in x test prediction, and then compare the predicted value with the actual value stored in y test, using the same accuracy underscore score function, and then print out the score, which is to be 77%. Finally, let us create a custom predictive system. This code snippet takes the input from the user and predicts whether they are diabetic or not. Uh, let's see. Here we took a total of 8 values, which represent all the pregnancy, glucose, BP, age, and rest of the feature column. Then we convert it to a NumPy array, reshape it using dot reshape, and apply scalar transform on it as we did previously. Then we use our trained classifier model to predict the outcome of this new variable std underscore data, and then print out the predicted value. We then use if else statement here, which gives the output of whether the person is diabetic or not, depending on the output prediction. So if the prediction is gives a 0 value, then the person is non-diabetic, and if the predicted value is 1, then the person is diabetic. As you can see here, initially we printed out std underscore data, which we got the standardized value as this. And then we applied our classifier model on this new variable, standardized variable, which gave us a predicted value of 1. And as we got this one value, according to the if else statement, the person is diabetic.